Ever wonder why your hair stands up when you rub a balloon on it? Well, my friends, that's the magic of electricity and magnetism at work. You see, electricity and magnetism are two forms of energy that love to interact with each other. They're like two best friends that can't be separated. Let's think about that balloon. When you rub it on your hair, you're creating what we call static electricity. This happens because some tiny particles called electrons jump from your hair to the balloon. Now, your hair misses those electrons and tries to reach back for them, causing your hair to stand up. Funny, isn't it? But electricity is not just about funny hair tricks. It powers our lights, our computers, and so much more. And the best part? It loves to play with its best friend, magnetism. Imagine that. So static electricity is like a tiny magic trick we can all do. But there's another type of magic. Magnetism. Ever played with magnets and felt that invisible push or pull? That's magnetism. Magnetism is a force that acts at a distance, much like gravity. It's a fascinating invisible force that's all around us. Now let's think about a common magnet like the one stuck to your refrigerator. Every magnet has two poles, a north pole and a south pole. If you've ever tried to push two magnets together, you might have noticed something strange. The magnets either pull together with a snap or they push away from each other. That's because opposite poles attract, while similar poles repel each other. So how does this work? Well, it's all due to the movement of tiny particles called electrons. They create the magnetic field around the magnet that leads to this invisible push and pull. So next time you're playing with those fridge magnets, remember you're not just doodling, you're exploring the invisible world of magnetism. So magnets are like invisible superheroes. They can push and pull without touching anything. Did you know that electricity and magnetism are best friends? We know it sounds a bit funny, but it's true. They're like two peas in a pod, always showing up together. Here's how it works. When electricity flows through a wire, it creates an invisible force field around it. This force field is actually a magnetic field. So, by simply turning on a light, you're creating magnetism. Now let's flip the script. Do you remember playing with magnets as a kid? Well, those same magnets can create electricity. When a magnet moves around a wire, it can cause electrons to move, and voila, you've got electricity. This is how generators and power plants work. They use magnets and wires to create the electricity that powers our homes, schools, and even our video games. This magical relationship between electricity and magnetism is called electromagnetism. It's like a secret language they share. So, electricity and magnetism are like best friends who can't live without each other. So, where do we see this magic of electricity and magnetism in our world, you may ask? Well, let's dive in, shall we? The magic of electromagnetism is everywhere. It's in the electric motors that power your toys and household appliances, making them whir and buzz to life. It's in the speakers that play your favorite tunes, vibrating to the rhythm of electricity and magnetism. It's even in the Earth's magnetic field, an invisible shield that protects us from harmful solar radiation. And guess what? Every time you use a compass, you're seeing electromagnetism in action. The needle of the compass aligns itself with the Earth's magnetic field, pointing you in the right direction. So, the next time you flick a switch, spin a toy, or jam to your favorite beats, take a moment to appreciate the magical dance of electricity and magnetism that makes it all possible. So, next time when you see a light bulb, remember it's not just light, it's a magical show of electricity and magnetism.